Alright, so today we will be talking about atoms and specifically what an atom is. So, an atom is, as we know, a very small thing that basically makes up everything that is real. Like, I'm made of atoms, you're made of atoms, everything in your room or wherever you are is made of atoms. And an atom has three parts to it. It has, sorry about that, neutrons, and the neutron is where the atom has most of its mass. So, mass, and it has no charge, right? So neutrons, they're pretty big, but they don't have a charge. Protons, on the other hand, do have a charge. They have a +1 charge, right? And then electrons, where you might be able to guess, have a -1 charge. So, you know all this, right? You get these three parts to an electron, but to an atom. But then you wonder, it's like, what does the atom itself actually look like? So there are a number of models for the atom, but the easiest for our brains to kind of visualize is the Bohr model, where you have your protons, which I will draw with a little circle and a plus, and your neutrons, which I'll just make a circle covered in black. And then you have your electrons, which have a negative charge on the outside. And they kind of go into these little rings, which we call orbitals. Or not really orbitals at this level, but it's more like it's a valence shell. So for an atom to really be happy, which isn't the correct way of saying it, but it's really just being stable. So for an atom to be stable, it would prefer to have these shells, these valence shells, satisfied. So that would mean for the inside, which is the only one that has this, it would have 2 electrons, right? Because that would satisfy the inner ring, if you will. And you will learn more about that into chemistry and why it does that. But for now, you just have to remember that is what happens. But once you get out from this first shell of the atom, then you kind of go into these other shells where you can fit a lot more electrons in. And you can fill these shells up to 8, right? So for an atom to be stable, it would prefer to have 8 shells in its valence shell. It would prefer to have 8 electrons in its valence shells over here, right? And there's a way that they can gain more and lose electrons by interacting with other atoms, but we'll get into that another day. So another thing that you have to remember about atoms is their way of taking the mass, or what is the mass of an atom. So the mass of an atom is measured in AMU, which is atomic measurement unit, I believe. And this is just, it's kind of a made up value where, because scientists really have no way of actually measuring an individual atom, but just know that if you ever look at a periodic table or are ever asked about the mass of an atom, this is what you would be measuring it in. So, you have that. You have, you have this little inwards thing in the middle of an atom, right? So you think it's like, well, what is that? Like, I know the electrons, they go into the valence shells, and little fun fact, the electrons on the outermost shell are called valence electrons, and those are the ones that typically react in a reaction or are transferred in a reaction. But this little middle thing here is where the proton and the neutrons go, right? It is called the nucleus, and it is the sole center of an atom, and it has all, or what we consider all of the atom's mass is in the nucleus. So, whenever you are asked a problem about, well, how many neutrons are there, you would always look to the nucleus if you were given a diagram. So I'll erase all this. You can pause the video if you want to take notes, but I want to give you a little bit of practice. So here I will make this, and I will put that there. We'll go here, here, here. Alright. Now, can you tell me where the electrons are on this? Or how many electrons does this thing have? Yeah, it has 2 electrons. You have one there, and you have one there. How many protons and neutrons does it have? If you said 2 for each, you would be right, because you have one there, and one there. But one more thing is, what atom or what element does this atom represent? And if you did get this one right, then I would be very proud of you, because I've not explained this yet, but it would actually be helium. And you want to know why? It's because, since on the periodic table, helium, I can show you this real quick, periodic table, helium has 2, right? So it has 2, that is its atomic number. And if you also look at something, it has 2 protons. Now, that is the way that you are able to tell if an atom represents a certain element. So the way we distinguish elements from one another is based on their amount of protons. And you would look where? In the nucleus for the protons. You would take the amount of protons in the atom, and then you can find the corresponding amount in the periodic table. So let's say if you had 5 protons in an atom, what element do you think it would be? So if you said boron, you would be right, because as you can see in the top left, you see boron has 5, and that means that it has 5 protons in the middle. And protons are always different for each element. They are the same no matter what for each element. So for helium, you could change the amount of electrons. It could somehow, actually helium probably would not gain an electron, but let's just say it can. So somehow it could gain electrons in a miraculous new invention, but the amount of protons in helium would always stay the same. And so would the amount of neutrons. So that is it for today. I hope you learned a little something about how an atom looks, or like maybe be able to picture what an atom looks like, the parts of an atom, and how you can identify an atom based on the parts of it. And I hope you have a good day. Thank you.